Interstellar Object 3I Atlas has now entered the field of view of Mars spacecraft, and the mystery surrounding it is only growing deeper. In early October, the object passed within about 30 million kilometers of Mars, becoming the first interstellar object ever photographed from another planet. Several spacecraft observed it closely, including the European Space Agency's Trace Gas Orbiter and Mars Express, along with NASA's Perseverance rover. But the observations raised an immediate question: where was the comet tail? Even though 3I Atlas had already shown signs of activity, the Mars images did not reveal the kind of obvious tail scientists would normally expect. At the same time, researchers detected something even stranger. NASA's Swift Observatory found evidence that the object was releasing a large amount of water, even while it was still far from the Sun. That unusual behavior has made 3I Atlas even more difficult to classify. The reason Mars spacecraft were able to capture it in the first place is fairly simple. From Earth, 3I Atlas was positioned almost directly behind the Sun, making it extremely difficult for ground-based telescopes to observe. From Mars, however, the viewing angle was much better. That gave orbiters around the red planet a rare opportunity to photograph the object without the Sun blocking the view. The Trace Gas Orbiter managed to capture 3I Atlas as a faint, diffuse point of light against the darkness of space. What appears in the image is not the solid nucleus itself, but the glowing coma surrounding it, the cloud of gas and dust released from the object as sunlight energizes the material escaping from its surface. The coma stretches across thousands of kilometers, confirming that the object is clearly active. Still, no obvious tail appeared in those images. Scientists believe that is likely because the object was still in an early stage of activity, with the released material not yet forming the long, distinct tail commonly seen in more developed comets. A visible tail may become easier to detect as 3I Atlas moves closer to perihelion, its closest point to the Sun. Even without a dramatic tail, these images were considered a major achievement. According to experts, 3I Atlas was between 10,000 and 100,000 times fainter than the kinds of targets normally photographed by the Trace Gas Orbiter's camera. Capturing it at all was an impressive technical success. Other Mars missions also attempted to observe the object. Mars Express, which has been studying Mars since 2003, turned its instruments toward 3I Atlas as well. Its viewing method was different, using shorter exposure times and combining multiple images afterward in an effort to detect the faint target. Scientists are also analyzing spectral data from both Mars Express and Trace Gas Orbiter to learn more about the object's chemical composition, although those results are still being evaluated. NASA's Perseverance rover also managed to image the object from the Martian surface. On October 4, one of its navigation cameras recorded a faint streak of light moving across the night sky over Jezero crater. But that streak was not a true comet tail. It was mostly a visual effect caused by the camera's resolution and the object's motion during the exposure. In reality, the nucleus of 3I Atlas is estimated to be at most about 5.6 kilometers wide, surrounded by its much larger glowing coma. Meanwhile, ground and space-based observations have revealed something even more surprising. NASA's Swift Observatory detected a strong signal of hydroxyl, which forms when sunlight breaks apart water molecules. Because of that, hydroxyl is considered a reliable indirect sign of water. What shocked scientists was just how active 3I Atlas appeared to be at such a great distance from the Sun, nearly 3 times the Earth-Sun distance. Normally, water in comets begins to vaporize much more strongly only when they move significantly closer to the Sun. But in this case, researchers measured a hydroxyl signal corresponding to an enormous water release, roughly comparable to a fire hose blasting about 40 liters per second. To explain that amount of water through normal sublimation from the nucleus alone, at least 8% of the surface would need to be continuously active. That is unusually high. Most comets in our solar system typically show active surface fractions below 5%. Because of that, scientists suspect a more complex process may be involved. One leading idea is that the object is releasing tiny icy dust grains from its nucleus, and those grains then evaporate in the surrounding space, feeding the coma from outside the core itself. If that is true, it could point to a layered internal structure and a formation history unlike what we usually see in solar system comets. That comparison becomes even more striking when 3I Atlas is placed alongside the 2 previously known interstellar visitors. Oumuamua showed little evidence of water, while 2I/Borisov was rich in carbon monoxide but displayed only moderate activity. 3I Atlas, by contrast, appears to be showing strong water-related activity even at a large distance from the Sun. That suggests an important idea. Every interstellar visitor may carry a distinct chemical fingerprint from the planetary system where it formed. For scientists, that is what makes 3I Atlas so valuable. It is not just another unusual object passing through the solar system. It may be a direct sample of chemistry from another star system, offering a rare chance to compare our own solar system with worlds formed far beyond it. Many questions remain unanswered, but one thing is already clear: 3I Atlas is behaving differently from any comet we know. And as it continues its journey through the inner solar system, astronomers will keep watching closely, hoping this strange visitor reveals something new about how planetary systems form across the galaxy.